Okay, we'll get back to functions, section 1.1. Remember, the function is a rule that takes an input value and assigns one and only one output value to it. So here's where we left off in the last video. We take a look at this example. Suppose we have a function, f of x equals 3x squared plus 5y, or plus 5x minus 2, okay? And I want us to compute these 6 items here. And so I'm doing that on the next page. In part A, we want to find f of negative 3. Okay, so here is f of x. F of negative 3 means that wherever I see an x in f, I need to replace that with negative 3. And there's a couple of x's showing there. So when I replace x with negative 3, let's see, negative 3 squared is 9, times 3 is 27, minus 15, minus 2. Now, when I replace x with a negative 3, I want to make sure that I have parentheses around the negative 3. Because negative 3 squared with the parentheses is 9. Negative 3 without the parentheses is negative 9. I get two different, answers there. Okay. 27 minus 15 minus 2 gives me 10. Okay, so f of negative 3 is 10. What that means is that the point negative 3, 10 would be one point on this graph, if I were to graph this curve. Okay. In part B, I want us to find f of x equals 0. Okay, well, f of x is 3x squared plus 5x minus 2, and I'm setting that function to be equal to 0, and I'm going to solve for x. Now, when I set that equal to 0, I form what's called the quadratic equation. We're going to do lots of things with quadratic equations a bit later. Okay, but regardless of what I mentioned there, the first thing that you always want to think of whenever you're solving a quadratic is if it factors. Factoring by far and away is the easiest method to solve. Okay, now not all quadratic equations factor, so there is more to know with this. But now if I set 3x squared plus 5x minus 2 equal to 0 and try to factor this, this should factor nicely. So first, outer, inner, last. Let's see. The factors of 3 are 1 and 3, so it's going to be 3x and x. The factors of 2 are 1 and 2. Now, it's a negative 2 at the end. So what that tells me is that the signs have to alternate, either plus, minus, or minus, plus. Now, I'm trying to get a 5x in the middle. Okay? And so I went 3x minus 1 times x plus 2. Now, how do I know that's right? I can check this. So if I FOIL this back, first, outer, inner, last, I should get the line right above. Okay, so let me check this. 3x times x is 3x squared. The outer terms, you get 6x, and then minus the inner terms, the minus x. 6x minus x is 5x in the middle. That looks good. And then the last term is negative 1 times 2 is negative 2 at the end. That looks good. Okay, by the way, you'll always know if you've factored correctly. You can FOIL it back and check and see that you get the line right above. Okay. Factoring is something that won't go away. Okay, factoring is something that we should constantly try to get better at. And just like anything else, that's the more you practice, the better you get. Okay. Well, now I can set each factor equal to 0 and solve. So I got 3x minus 1 equals 0 and x plus 2 equals 0. Over here, if I add 1 and divide by 3, x equals 1/3, that's going to be one answer. And then over here, x equals negative 2, that's another answer. By the way, you'll always have two answers whenever you're solving a quadratic, okay? So it's something like this function, where you have a form of ax squared plus bx plus c, okay? So again, more on that later on once we get there. But okay, the next thing is what if I had f of x plus f of negative 3? Well, f of negative 3 is 10, f of x is 3x squared plus 5x minus 2. So all I'm saying with this is to add 10 to the function. Okay, well, if I do that, at the end here, negative 2 plus 10 is 8. So I get 3x squared plus 5x plus 8, and I'd circle that. That'd be the answer. Okay. In part D, I want us to find f of negative x. So just like in part A, I'm supposed to replace x with negative 3. In part D, I'm supposed to replace x with negative x and simplify. Again, make sure that you got the parentheses around the negative x's, because negative x squared with the parentheses is x squared. Negative x squared without the parentheses would be negative x squared. Those are two different things. Right? So I got negative x squared with the parentheses, that's x squared. There's a 3 in front of that, so it'd be 3x squared leading off, minus 5x minus 2. Okay, I'd circle that answer there. Now that's going to be different from what I'm asking for in part E. Part E, I want us to find negative f of x. So negative f of x means to take negative the whole thing of 3x squared plus 5x minus 2. That's the function. So I want to take the opposite of that. Throw parentheses around the function because you're going to distribute the negative into these three terms here. And so that's going to give us negative x squared minus 5x plus 2. Okay, now something to mention. Notice how our answers for parts D and E are different. That shouldn't surprise us because we're doing two different things. Right? In part D, we're saying replace each x with a negative x and then simplify. In part E, we're taking the opposite of the whole function. Okay, so maybe it's not surprising to us that we were getting two different answers there. Okay, because we were doing two different things. But now sometimes f of negative x is the same thing as negative f of x. Okay, when that happens, it's called an odd function. We'll talk about even and odd functions in another section here. But just realize that you're doing two different things there. Okay. Part F, we want to find f of x minus 3. So everywhere that I see an x in F, I need to replace that with x minus 3. There's two x's there to replace. So I'm looking at 3 times x minus 3 squared plus 5 times x minus 3, then minus 2. Now I got to simplify that. X minus 3 squared, that's the same thing as x minus 3 times another x minus 3. When I FOIL that out, that would be x squared minus 6x plus 9. Okay? And then I'm going to distribute this 5 into these two terms, so it'll be plus 5x minus 15, and I got the minus 2 at the end. Next thing, let's distribute the 3 into these three terms. Okay? So that's what I'm doing right there. I got 3x squared minus 18x plus 27 plus 5x minus 15 minus 2 is at the end. Okay, and then I'm going to combine my like terms there. So I got 3x squared and then negative 18x plus 5x, that's minus 13x. And then 27 minus 15 minus 2, that's plus 10 at the end. Okay, go ahead and circle that. Now, something else to mention. Notice how our answers from parts C and F are different. That shouldn't surprise us because we're asked to do two different things in part C and F. Right? In part C, we're saying take the function 3x squared plus 5x minus 2 and then add f of negative 3. F of negative 3 was 10. So just add 10 to the function. Okay, we did that. Okay. In part F, we're saying everywhere that we see an x in F, replace that with x minus 3. And then simplify. Okay, we did that. Well, that's different from what we were doing up here, right? So maybe it's not surprising to us that we did get, a different answer because we're doing, something totally different there. Okay, now sometimes it will happen where these two things are the same. Okay, and when that does happen, that's special, I guess. So we'll talk about special properties of functions in another section there. Okay. Let's see. Let's take a look at this next one. This next thing is a definition. It says, if it's possible to solve an equation of y in terms of x, then we write y equals f of x, and we say that f is given explicitly. In other words, y and f of x, those mean the same thing. Okay? An equation is in what's called implicit form when it's not in explicit form. So if it's not possible to solve an equation for y, or if you get multiple y values, we'll take a look at an example with that. So here's an example. Like suppose that I have an equation written in implicit form. Okay, and I got 3 different equations written in implicit form. And all I'm saying with that is that I have an equation and it's not solved for y. That's implicit form. Okay, let's get that equation into explicit form. Explicit form just means that you can solve for y. Okay, so this first equation here, let's go ahead and subtract 2x. So I get y equals negative 2x plus 3. Now I'm in explicit form. Now when you're in explicit form, y and f of x mean the same thing. Okay, so I could call this y equals negative 2x plus 3, or I could call this f of x equals negative 2x plus 3. That's the same thing. Okay. Here's another example. So I got x squared minus y equals 6. That's an implicit form because it's not solved for y. And if I solve this for y, that's add y to both sides and then subtract 6. So I get y equals x squared minus 6. Now I'm in explicit form. And y and f of x are the same thing. So if I wanted to, I could call this a function. I could say f of x equals x squared minus 6. That means the same thing as y equals x squared minus 6. Okay. Here's another example. X times y equals 5. X times y equals 3. Yeah, it's an implicit form because it's not solved for y. If we solve this for y, let's go ahead and divide both sides by x. So I got y equals 3 over x. Now I'm in explicit form. And y and f of x are the same thing. So if I wanted to, I could call this a function. I could say f of x equals 3 over x. That means the same thing as y equals 3 over x. Okay. Now, not all equations define a function, y equals f of x. If an equation is solved for y and more than one value of y is obtained, then the equation does not define a function. So if we take a look at an example of this here, I want to know, is the equation x squared plus y squared equals 1 a function of x? Okay, well, let's go ahead and get this into explicit form. Right now we're in implicit form, right, because the equation has not been solved for y. So let's go ahead and solve it for y. I'm going to subtract x squared from both sides. I got y squared equals 1 minus x squared. And then we'll take the square root of both sides. Whenever you take the square root of both sides, you always have to tack on a plus minus onto the right. Don't forget about that necessary thing. Always tack on a plus and minus whenever you take the square root of both sides in an equation. Okay? The square root of y squared is y. So y is equal to plus or minus the square root of 1 minus x squared. Okay? Now, we're in explicit form, but notice how I wouldn't have a function because remember the definition for a function. That's the first thing I talked about in this section. It says for each value of x, there's only one value of y. There's not a plus y and a minus y. There's only one value of y. Okay? So this equation would not be a function. Now this is the equation of a circle. Circles are not functions. Okay? They're going to fail the the vertical line test, right? We talked about the vertical line test there in the last video. So if I drew a graph of a circle, you know, it's going to, and apply the vertical line test, a vertical line will intersect the circle in more than one point. So circles are not functions. Okay. All right, we'll go ahead and stop the video right here. I got a little bit more in this section left, and we'll cover that in the next video there. Okay.